What's up, Algebra 2 students? Let's finish off Unit 6, finish off the first semester with a new concept. Okay? We're going to keep doing what we've been doing, which is solving quadratic equations. But we're going to be introduced to something brand new to all of you, which is the concept of an imaginary solution or a complex number. Okay? Step one is I want you to sketch these. Now, this is really quick. I just want you to remember what happens when we graph x squared plus 9. Everything's above the x-axis. There are no x-intercepts. I mean, I could do this without a calculator. X minus 1 squared plus 4. This is in vertex form. That means my vertex is at h comma k, which is 1 comma 4. Remember, vertex form was x minus h squared plus k. So 1, 4. I know a is positive. A is 1. So I'm going to be opening up from there. I could use negative b over 2a to graph this one, but let's just quickly figure that out. Negative x squared plus 2x minus 3. Everything's below the x-axis. We have a vertex at 1, negative 3. Everything's below the x-axis. And we got that, okay? So what we said is that the x-intercepts are the solutions. So like the x-intercepts when y is 0, like what are the solutions to these? And we've been saying that there are situations when you have no x-intercepts, so that there's like no solutions. Okay? But we've included something recently. I don't know if you've noticed. Many of you probably haven't, and you've just been writing no solutions. We've been talking about no real solutions, no real numbers that can solve this, okay? Because turns out there are solutions to these equations. There are solutions to these equations set equal to 0. We're going to see that. They're just numbers that we really haven't seen before, okay? The numbers come from taking square roots of negatives. Now, you can do this at home. Can you plug these into your calculator? Tell me what you get. I have a calculator right here. We'll use Desmos as well. Like, what do you get if you plug in the square root of negative 1? Calculator's like, no, error, right? Error. You do that for all the other ones, and you're going to get an error, square root of negative 9. Error, okay? And same thing is what you'll see. You see an error. But they give you a little hint here. They say there's a non-real answer. Okay. That's because these aren't real numbers. The square root of negative 1, can't do. Square root of negative 9, you can't do. Square root of negative 4, you can't do. But they are numbers, and we're going to call them imaginary numbers. Okay? Okay? Like, what do you mean you can't do these? Like, try to solve this equation. X squared equals negative 9. Think about, is there a number that multiplied by itself can give us negative 9? And the answer is no, right? Like, you could think about negative 3, but negative 3 times itself is positive 9. You think about positive 3, and yeah, you get positive 9. So that there's no real number that we know of that when we square, you get negative 9. But what if I put in the square root of negative 9, right? Well, if I take the square root of negative 9 and square that, don't square roots and squares cancel each other out? Wouldn't I get negative 9? Yeah, so like turns out this is an answer to this equation. square root of negative 9 is an answer. Because when I square roots, they go away. So we now understand that square roots of negatives, though they can't exist, are answers because it works. So since we know it works, we're actually going to call this like an actual thing. We're going to call this an imaginary number. And we're not going to write it as the square root of negative 9. We're not going to write it as the square root of negative 1. We're going to just say that it is an imaginary number I. I stands for like imaginary. What do you mean by imaginary? It's using the square root of a negative number, which you can't do. It's more of a concept. Okay. Now, watch what we're going to be doing. We're going to be eventually solving equations x squared equals 16. And we'll be simplifying things like square roots of 20s. But instead of 16, it's going to be negative 16. Instead of 20, it's going to be negative 20. Okay? Now, remember how we simplified? To simplify, we would write it as a product of two things. One is the biggest perfect square, and then the other is the other. Result is squared. Well, now we're just going to have one extra thing. The square root of negative 1. It's kind of like an unnecessary thing, and we can put it at the end, actually, probably better. All I'm saying for you guys, and the key to the lesson, is that if you're taking the square root of a negative number, it's going to be imaginary. We're going to have an I after it. I stands for it's imaginary. It's got a square root of a negative in it. If you have x squared equals negative 16, your answer isn't plus or minus 4. Your answer isn't plus or minus negative 4. Your answer is plus or minus 4i. The square root of 16 is 4, but really, this is the square root of 16 times the square root of negative 1, which will be 4. And the square root of negative 1 we're going to call as like imaginary. It's like the simplest imaginary number. Vince's is the best. That guy? Or is that Fred? That's Fred. No, that was Vince's. He's the best. I swear he's the best. Okay? Vinny. He is the best. So, the square root of a negative, we're going to say is imaginary. Now, what we're going to be doing is like having these as square roots. Square root of negative 9. And here's what I want you to do. Pretend like it was positive. Okay? If it's positive 9, what's the square root of positive 9? This is what I always tell my students to do. Like, start by plugging in the square root. Does it work? Great. That's your answer. 3. But it's not 3. It's imaginary because it's the square root of a negative. That's what I tell my students to do. It's just kind of be like, your answer is going to be imaginary because you're taking a square root of a negative. You can't do that. But it's like, pretend if it's positive 9, you get the square root of 9 is 3i. The other way to do this is to say, this is square root 9 times square root negative 1, kind of like what we've been doing. And we'll say the square root of negative 1 is imaginary. Okay? A square root of a negative is imaginary. And the square root of 9 is 3. Okay? So pretend the 4 is positive. The square root of 4 is just 2. Use your calculator to do it. But since it's a square root of negative, it's an imaginary. You could write this as root 4, root negative 1 if you wanted to. And then the square root of negative 1 we'll call as I. Square root of 4 is 2. Let's try 5. Nope, can't do the square root of 5. Now this is when we try to simplify. If this was any other number, try to divide it by perfect squares. Remember all of our perfect squares? Square root of 4, 2, square root of 9, 3, square root of 16, 4, etc., etc., etc. Okay, try to divide by those roots. You can't. So all this is root 5 times root negative 1, which is root 5i. It's the square root of a negative. It's an imaginary number. It will solve some of our equations. But It's not a number that we know or we can see. You can't see, you're not going to be able to see the solutions on a calculator or on like by graphing. Square root of 8. Can I square root 8? Nope. Can't. Can I divide 8 by one of these perfect squares? Yeah, I can divide 8 by 4. 8 by 4 is 2. 4 times 2 is 8. Remember how we were simplifying? We want to write this as the product of the biggest perfect square and the biggest, and then whatever's left over, what's left over. But we also have the square root of a negative 1 after this. 2 root 2 I. Now, what I tell my students is kind of like, you don't have to worry about this square root negative 1. Just like pretend this is positive. Simplify it. Make sure you have an I after it. Okay? They're not real numbers. They are imaginary. Square root of 3, can't do it. So we would write this as the square root of 3. That's imaginary. It's an imaginary number. Okay? Or times the square root of negative 1. Square root of 32. Well, let's see. Can 16 go in there? Can 9 go in there? Let's see. 32 divided by 16. Yeah, it's 2. Okay, so remember, this is how we simplify. This is good practice. Root 16, root 2 is 32 written as a product of a big perfect square and another number that doesn't have a perfect square in it. The square root of 16 is 4. This is why we do this. We get 4 root 2. It's the square root of negative, so it's got an I next to it. It's got the square root of negative 1. Negative 16. Well, I know the square root of 16 is 4, so I'm going to say I have 4 i's, or, an imaginary 4. A square root of a negative times 4. 20. I think I can fit 4 and 20. That's the biggest perfect square that goes in there. So this is root 4 times root 5, right? 4 times 5 is 20. So root 4 times root 5 is 20. This also has a negative 1 in it. So I have 2. Square root of 4 is 2. Square root of 5 cannot be simplified. It's ugly. 2 root 5i. Okay? Cool. So we're going to have solutions that look like this, that are going to be plus or minus 4i, or plus or minus 2 root 5i. These are our solutions, okay? And we're going to be solving our equations the same way that we did in day 1, which is using square roots. It's really day 2 using square roots, and day 3 using the quadratic formula, okay? So like take this one, x squared plus 9 equals 0. We already graphed it. We already see like there's no visible solutions. There are no real numbers that solve this, but the square root of negative 9 solves it. But I'm going to write it a little bit differently. So what do you do? What do we do day 2? We isolated our square since there's only one square. We then square rooted both sides. Since we're using a square root to solve an equation, we need a plus or minus. We've done this. The square root of 9 is just 3. But since this is negative 9, we're going to say this is 3i. Now, these are our solutions, positive, negative, 3i. Because if I plug in 3i, I'm just going to show you this, 3i squared plus 9 equals 0. Well, that's 3 times I is replacing the square root of negative 1 squared. Well, 3 squared is 9. The square root of negative 1 squared is just negative 1. This is negative 9 plus 9. That works, okay? So there's no real number, but having a square root of a negative does work in this original one. Or really, like, you could say 3i which is being squared plus 9 is 0, you could say, oh, 3i is just the square root of negative 9. Well, the square root of negative 9 is just negative 9. The square root of negative 9 squared. The square root and the square cancel. Boom. It works. Okay. And it works with negative 3i too. So these are our solutions, these imaginary solutions. Remember the other procedures? This is in vertex form. Isolate the square, even if it's a bunch of stuff. We then square root both sides. Simplify the square root. Okay, the square root of negative 4. Think of it as just a positive 4. You can't plug in negative 4 into your calculator. Calculator says, nope, not going to do it. But the square root of positive 4 is 2. So this is going to be, root 4, root negative 1. It's almost like pull out the negative 1. Simplify this. This is just 2i. We get x minus 1 because the square and the square root goes away. The parentheses are gone. Now remember, you're solving an equation using a square root. You need a plus or minus. This also shows up with the quadratic formula. Finish things off by adding 1 to both sides. I don't care where you put the plus 1, just don't try to add it to this. You get positive 1 plus 2i, positive 1 minus 2i. These are our solutions. Okay, you plug this into the original equation, it actually works. Then we go into day 3. Guys, we can use the quadratic formula. This is how we solve standard forms using square roots. It's coming from completing the square. We have to identify A, B, and C. We then plug those numbers into the formula. If B was negative, it'd be positive. But B is positive 2, so I got negative 2 over, I'll use this form, over 2 times negative 1. Do this math. 2 times negative 1 is negative 2. Negative 2 divided by negative 2 is positive 1. Use the fraction button in your calculator. If you can't get that, or if you're not comfortable with your mental math, please use your fraction button. That way, you're not typing it in wrong in the home screen. Don't tell me this is something else. Okay, get positive 1 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, let's work in the square root. What is inside the square root is b squared minus 4 times a times c. We could use parentheses, and I get negative 8. What's the square root of negative 8? Well, we have to simplify that. Root 8 times root negative 1. Maybe we do it this way. Root 8 is 4 times 2. I use 4 because it's a big perfect square that goes into 8. We've done this plenty of times. Hopefully we're used to it. Square root of 4 is 2. Square root of 2 is just the square root of 2. The square root of negative 1, we say, is imaginary. It's I. It's this number that doesn't exist. We can't think of a number times itself, but it works. It works in our equations. Okay, so this is 2 root 2i over negative 2. I could take the 2 and divide it by the negative 2 and have negative root 2i. Now, it turns out when you add or subtract negative root 2i, it doesn't matter if it's negative root 2i or positive root 2i. It's almost like I could have divided everything by negative 1 and gotten the right answers. So I don't want to confuse you. This is right. 1 plus or minus negative root 2i, which is the same as 1 plus or minus positive root 2i. 1 plus negative root 2i, 1 minus negative root 2i. This turns into a minus, this turns into a plus. So see how they're the same. That's listing them off separately. This is listing them off together. Okay. And that's it, guys. You just got to pick the right method. And like just after you square root, you see you have a square root of a negative. You can use your calculator like to help you. What's the square root of -8? Oh, yeah. Our answer's imaginary. So it's going to be the same as square root 8 times I. All right, so let's pick the right method to solve the equation to get two imaginary solutions. This is standard form. So I'm going to use the quadratic formula. A is 1, B is -4, C is 5. X equals, use the quadratic formula for the page above, the opposite of B over 2 times A. Add or subtract the square root of B squared minus 4 times A times C all over 2 times A. 4 divided by 2 is just 2. Let's work inside the square root. -4 squared minus 4 times 1 times 5. It's -4. The square root of 4 is 2. The square root of -4 is not -2. It doesn't exist. It's imaginary. This is where we say, oh, the square root of -4 is just like the square root of 4, but it's just imaginary. The square root of 4 is 2. So the square root of -4 is 2i. Two divided by 2 is just 1. I get 2 plus or minus I. So that's 2 plus I, 2 minus I. Those are the answers. You won't be able to see them. You can't graph them. You can't really see like the imaginary solution. This is just what it is. These numbers would work in the original with a square root of a negative. 2 plus square roots of negatives. They work in the original. Let's try this one. Okay, I would use square roots. Vertex mode. Instead of the quadratic formula, which uses square roots. I don't want that to be confusing. It's just, I would isolate the square root. Isolate the square. Don't square root yet. Divide by 4. Get -9. Square root both sides. Okay. You can't type in the square root of -9 and get a number, but it's an imaginary number. The square root of 9 is 3. You could write this as root 9 root -1. Square root of square root of -9 is 3i. Square root of 9 is 3. Square root of -1. Oh, we have an imaginary number. But over here, just gets rid of the square. We have x minus 2. Remember, these all have pluses or minuses, right? The quadratic formula reminds you, you need a plus or minus if you're using a square root to solve an equation. I square rooted -9. I need a plus or minus. Add 2 to both sides. It doesn't matter. Just make sure you understand that you have a positive 3i and a negative 3i that you are adding 2 to. Doesn't matter which order it goes. Same deal, I would isolate the square here. Could I use the quadratic formula? Sure, if b is 0. But since I just have x squared and it can be isolated, I'm going to isolate the square and square root. How do I do that? Subtract 18. Oh, wait, it wasn't a goal, but that's a goal. Oh, not good for Brazil. I guess Vinny's goal was called back because of his offsides. Ronaldo, old school Ronaldo, Brazilian Ronaldo has gained some weight. Oh gosh, that's beautiful. Oh my gosh. That's just beautiful. That's so beautiful. Brazil scores beautiful goals. Goodness gracious. All right. Okay, this is a good one. 18 divided by 3, -6. Ready to square root both sides. Okay. X equals plus or minus. Square root gets rid of square. What's the square root of -6? It's an imaginary, so we don't just like give up. We say, okay, it's got to be something with an I attached to it. So start with the square root of 6. Okay, can't do it. Can you divide 6 by the perfect square like 4? No. So root 6 is actually completely simplified. So my answer is actually root 6 times I. This turns into root 6 times root -1. You can't simplify root 6. It has to stay as root 6. A lot of you students are confused. When do we keep the root and when not? It's like you got to figure it out. And the square root of -1 turns into I. So my solutions are plus or minus root 6I. All right. X squared plus 3x plus 4. Oh, could you isolate a square? No, this is like standard form. This is ax squared plus bx plus c. I'm going to use, my friend, the quadratic formula. Okay, x equals opposite of b over 2 times a. Okay, well, that's just -3/2. That's ugly. Plus or minus square root b squared minus 4 times a times c all over 2 times a. The square root, what's inside of it? 3 squared minus 4 times 1 times 4. It's 9 minus 16, which is -7. What's the square root of 7? Because I can't take the square root of -7. Square root of 7 can't be done. I can't divide 7 by any nice number. So I'm going to keep this, as ugly as it may look, as root 7I over 2. You could also have it in the other quadratic formula form, which is like that, okay, with the 2 on the bottom. All right, that's it. That's the lesson. Imaginary numbers work. They can solve these quadratic equations, but you can't see them, but they do solve it. Imaginary numbers show up a lot in more and more advanced mathematics as potential solutions to really, really tough equations. So this is our first introduction to that. You guys probably won't see them for the rest of the class. You know, maybe for more advanced equations and finding like zeros. But that's it, the extent for your guys' exposure to imaginary numbers. Thanks.